Thanks, everyone. Hope you're ready to learn how the new California Consumer Privacy Act can help you safely preserve and manage the PII required with your networks, while also increasing the amount of network events ingested. Without requiring more hardware. This is important, right? Or software, or the crippling costs involved. So this is really all about making certain that security and network teams can ingest more data and ensure safe handling of that data to meet CCPA. So a little bit about me. I am a former Cisco Advanced Services Engineer, distinguished speaker and author, co-author of the CCIE Service Provider Exam. I've been doing this for over 20 years. We do have 2 US patents on this technology. All right, so we built LogZilla, which to enable network and security teams to really identify and mitigate and resolve. We wanted to get people away from this mentality of traditional tools where they just point out problems and bring you up to more of an advanced thing where you can actually solve these problems. So it's kind of like the difference of going to the doctor and him saying, hey, this hurts, hey, this hurts. Traditionally, tools just send you an email that say something's broken, go fix it. There's 3 main focus areas that we did with this. Having been at Cisco and seen the largest networks in the world, the first thing was the ability to ingest. Why is this important? When we talk about ingest speed and indexing speed, if you look at some of the products out there today, they tend to index around 100 gigabytes per day per indexer. And so when those companies say, hey, we're scalable, what they actually mean is our software isn't scalable, but if you throw 200 servers at it, it's scalable. But guess who has to pay for that? You do, right? So our system can ingest all of that data on a single server up to 36 terabytes a day. Obviously, if you have 1 server to manage versus 200 or 300 or 400, this is going to cost you a lot less. The next step is to enrich that data. Most log tools, I don't know of any other than ours actually, that enriches the data, right? This is the next step of get out of that log management, here it's broken, go fix it, or here, look at this screen and do searches, to let's tie in inventory systems. When an event comes in, let's find out every single thing we could possibly know about that so that the person doesn't have to do it. And within a split second of it coming in, you have everything you need to know. And then finally, a lot of the problems that we deal with on a daily basis, we already know how to solve. And that means if we know how to solve it, why don't we have the system go and do that? A simple example might be on the network side, an interface goes down. We get a line protocol down. Let's go check our change management system. See if there was a change, there was an authorized change. Go check our gold standard configs. SSH back into the switch, compare the 2, find out it's out of compliance, and put it back into compliance. All of that happens within a second. If we look at the way traditional monitoring tools work, most of the products still fall into this category. And this is what I was talking about, where you have to sit in front of a screen and you're doing searches and you're trying to find bad things. They really don't fix anything, they just point them out. And we move out of monitoring to management. And this is in terms of actually managing the data that comes in. That is, I see this, I need to go do that. But the problem is the scalability and the burden that's put on the customer to manage all of this. Even when they're managing the data, you've now become a manager of all the hardware involved in doing it. And then we finally move to the orchestration area. That's the O part of LogZilla Neo. And so what we're doing is bringing all of that together in order to lower the mean time to restore. If we're involving humans, you look at hours versus 2 or 3 seconds to restore services. Let's talk about real time, right? I mean real time as in this second, not in 5 minutes or 10 minutes. If you look at the top right, you'll see a screenshot of one of our systems that we're running at Cisco Live. It's about 11 terabytes per day on a single box. That's 250,000 events per second. getting away from that post-mortem analysis, and also eliminating complexity. When I install a product, I want to do it in a few minutes. I don't want to spend the next 3 months configuring it, setting it up, making sure it's working, or building dashboards for people. I should be able to just click, my users should be able to click, and it's done. So now we're going to talk about the cost of this, right? When we think about total cost of ownership, you think about what you actually pay for. And if we look at something like Splunk at 10 terabytes a day, it's actually about $80,000 per day, given the list price of the product, which is $531 per gig, right? So you've got the software costs over 3 years of around 30 million, but 109 million to operate the product, including that cost. Incidentally, our operating cost decreases because of that ability to scale. So now we're going to talk about why this happens. In every environment, logging, some S&MP traps, but data coming in, you get duplicate events. This is a real screenshot from a real customer. And you can see here that their network team pushed out a change. That's a standard Cisco event message. If we look at the top, we'll see that almost 1 billion events got generated, but 93% of those were the same thing over and over again. And you can see here it was one device in a single minute had pushed 70,000 events. The next minute, 90,000, 62,000. What happens when traditional management tools receive this data? Number one, they'll either drop it because they weren't tuned, or you had 200 servers and not 600 servers to do it. But even more common is that they just slow to a crawl. And guess what? This is when you actually need access to that data. Something terrible is happening. I can't get in. I can't do searches. I can't figure it out. One of the other features we do is we're able to do pre-duplication. That is, as the event comes in, we can dedupe that event in real time. We still track it down to the millisecond, but it reduces that noise and that burden of just spammy messages, right? But we can also sit as a preprocessor to other downstream consumers. So if we look here at the way this works, we essentially become that heavy lifter, and anything coming in, whether it's syslog, S&MP, Splunk, whatever, coming into the system goes to us. We do the deduplication. We also do the event enrichment, and then send it downstream. So now the result is these products actually got smarter, faster, better, stronger without the increased license cost, without the hardware cost, and their indexing and search and performance are better. And their knowledge is more. So now I've got an enriched event that says, hey, here's this device, here's where it's located. It's a WAN interface, here's the circuit ID, here's the service provider's phone number, here's the SLA on it. Or maybe it was a closet switch with a user port. It's the same message. We don't know if it's a user or a WAN circuit. Incidentally, this also gives you the ability to ingest everything. We talk to customers every single day who says, we have Splunk and we can't afford our license, so we're not logging everything. And that is absolutely mind-blowing. So, of course, this all sounds hard, right? Why don't we take a look at how it's done? We have very much focused the product around being easy, extremely easy to use. So we'll look at a screenshot of a dashboard here from our webinar today. You can see there's 6 million events, 66 of which are duplicates. And you can see on the Splunk side, there are about 2.5 million events. In this scenario, Splunk loses nothing. You get the same data. You're adding another column that says, here's the deduped count, and we still get our totals. So when you're creating your pie charts, they're still going to look the same. Everything acts the same. Splunk doesn't need every single message. It needs to know how many times it happened. On our side, for a forwarder, for the technical people, this is a JSON file. You can do it in JSON or YAML. But this is very simple once you know, once you can read this, right? The window size is, say, do it every minute. We're going to forward it out to syslog, to this host, which is the Splunk server and TCP. We can buffer to disk in case Splunk goes down. You can also rewrite things as they go through in real time. So I can rewrite this message, I can change it, I can manipulate it, I can do whatever I want to it. On the Splunk side, very easy to do. 2 files that are changed, you add this to your transforms and your props, and you're finished, and that's it. So now we go back to this TCO calculator, and we break it down at 10 terabytes a day over 3 years. I mentioned the 30 million cost, 254 servers when all is said and done, roughly, for Splunk, and your total cost of ownership at 109 million. And here's why. All of the hardware costs, all of the network infrastructure, you can only fit so many servers in a rack. Now you've got top of rack switches, now you have to pay network engineers, and of course IT labor skyrockets. So at the end of the day, that 531 per gig license is now $11,000 per gig for Splunk. You put us in front of it. Now you go from 254 servers to 59 servers and an $84 million cost avoidance over 3 years. That is mind-blowing. Incidentally, our cost of deployment with licensing, hardware, everything is less than the power it took to run that infrastructure. The entire process to implement is mere minutes. You switch the train tracks to us, we forward to Splunk, you're good to go.